Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Thank you. Right. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test, July 2025. In this video, we discuss the solution of a problem from the section Linear Algebra, and it is related to the concepts of quadratic forms. This question is placed in part B, which is a multiple choice question. It carries 3 marks. The question ID is 562954107. Further, this question is suitable for all these examinations. Right. The given question is, let V be the set of all ax cube plus bx square plus cx, where a, b, c belongs to R, set of real numbers. For f belongs to V, we define q of f is equal to integral -1 to +1 f prime t whole square dt, where f prime denotes the derivative of f. Which of the following statements is false? Note down, we have to find out the false statement. We are given 4 options. Option 1, Q is a positive definite quadratic form on V. Option 2, Q takes every positive real value. Option 3, Q of x is equal to 2. Option 4, for all f g belongs to V, Q of f plus g is equal to Q of f plus Q of g. Let's now discuss the solution of the problem in detail. We are given V is equal to the set of all ax cube plus bx square plus cx, where the coefficients a, b, c are coming from the real field. What is V? V is the set of all polynomials of degree at most 3 with no constant term. Observe here, the polynomials do not have ax cube plus bx square plus cx only. Actually plus d, the constant term must be there. But it is not given here. So, is a set of all polynomials of degree at most 3 with no constant term. Still, it is a vector space over R. Now, let us now take down option 4. For all fg belongs to V, Q of f plus g is equal to Q of f plus Q of g. If this is satisfied, means it is an additive property. But because of the presence of the square term, the integrand is a square term, the Q of f plus g coming out to be equal to Q of f plus Q of g is not possible, because this is a nonlinear term, right? For that reason, this may not be true. That's what we have guessed. That's the guesswork what we have made, and we are now trying to show that this option 4 is false. For that, we take a counterexample. Let f of x is equal to x. Yes. F of x is equal to x belongs to V. A is 0, B is 0, C is 1. So x belongs to V. So then f prime x is 1. Then Q of f, that is Q of x by definition, integral -1 to +1, f prime t dt, that is 1 square dt, that is integral minus 1 to plus 1 dt. So after integration t, from t is equal to minus 1 to plus 1, evaluate, you get it 2. And you also take g of x to be x only. As above, q of g is equal to q of x is equal to 2. Now, q of f plus q of g, in our case, it will be 2 plus 2 is equal to 4. Now consider fx plus gx, that is x plus x, that is 2x. Its derivative is 2. Now, the quadratic form of f plus g is equal to minus 1 to plus 1, f plus g prime t whole square, that is integral minus 1 to plus 1 2 square dt, that is 4 integral minus 1 to plus dt is 2. So 4 into 2, that is 8. On one hand you got 8, on the other hand you got 4, they are not equal. Therefore, q of f plus g is not equal to the q of f plus q of g. Thus, the option 4 is not true. Namely, we have to find out that statement which is false. So option 4 is false. And as this is the problem from section B, only one answer is correct. Therefore, the answer to this question is option 4. And that is the detailed discussion of the solution of this problem. Yes, we continue in the next slide. For the other options, I will show you they are all true. Right, option 1. Q is a positive definite quadratic form. Yes. Q is a quadratic form, basically. That I should have mentioned in the beginning itself. Q is a quadratic form. And option 1 concludes that it is a positive definite quadratic form. When do you say a quadratic form Q is positive definite? If Q of f greater than or equal to 0 for all f belongs to V, and Q of f is equal to 0 if and only if f is the 0 vector of V. Agreed? Now, Q of f, by definition, integral minus 1 to plus 1 f prime t square dt. It is always greater than or equal to 0. Why? Because f prime t is greater than or equal to 0 for all t. And this is true for all f belongs to V also. The integrand is greater than or equal to 0 for all f belongs to V. Right. That is why the integral minus 1 to plus 1 f prime t square dt is greater than or equal to 0. Now, if f of x is equal to 0, then q of f obviously equal to 0. Conversely, q of f is equal to 0. That implies, by definition, integral minus 1 to plus 1 f prime t whole square dt is equal to 0. This implies f prime t is equal to 0 for all t belongs to minus 1 to plus 1 closed interval. Why? Because f prime t whole square is non-negative and continuous. That's the reason f prime t. So this will give you f prime t is equal to 0. Integrating f of t is a constant. That means f of x is a constant polynomial in V. Who is the constant polynomial in V? So let us see. Constant polynomial means there should be a d. It is not there. For a constant polynomial, the coefficient of x cubed, the coefficient of x squared, the coefficient of x must be 0. So a is equal to b is equal to c is equal to 0. But there is no d term. This means f of x is equal to 0. F of x is equal to 0. So that is the 0 polynomial. F of x is equal to 0 is the polynomial. Right. So, yeah, a is 0, b is 0, c is 0. So it gives a 0 polynomial. So f of x is equal to 0. So q of f is equal to 0 if and only if f of x is equal to 0. Thus q is a positive definite quadratic form on V. Thus option 1 is true. Right. We move on to the second option. Option 2. Q takes every positive real value. Yeah. one thing is certain. Q, we have already shown that Q is a positive definite quadratic form. So that is sufficient actually. Q takes every positive real value. But Q of f will be greater than 0 for all f belongs to V, f not equal to 0. That's right. But will it take all positive real numbers? It is positive value it gives because it is a positive definite quadratic form. Will it, for every positive real number, can Q take every positive real number? That's the question. So for that, let us take f of x is equal to cx, where c belongs to R. Obviously, f of x belongs to V. Then f prime x is equal to c. Then Q of f is equal to integral -1 to +1 c square f prime t d f prime t whole square dt c square into integral -1 to +1 dt, that is 2. That is 2c square. So by choosing an appropriate value of c, 2 square can take any positive real number. 2 square can take any positive real number whatsoever by checking appropriate value of c. For example, you want to obtain a positive value, say k greater than 0. Then 2c square is equal to k, c square is equal to k by 2, c is under the square root of k by 2 belongs to R. So choose c is this. So thus, this will tell you that this 2c square can take any positive real value by choosing up an appropriate value of c. Thus, Q takes every positive real value. Correct. So the option 2 is true. Option 3 is this is true. What is the polynomial? Polynomial is x. We have already seen Q of x is 2. So Q of x is equal to integral -1 to +1. The derivative of x is 1 square dt. That is integral -1 to +1 dt. That will give you 2. So it is true. So option 3 is true. Right. And in this question, we have to find out that option which is false, which we have already seen. Option 4 is false. So the answer to this question is option 4. That is the detailed discussion of the solution of the problem from the section Linear Algebra, which is based on the concepts of quadratic forms. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes, I'm sure. I'm going to meet you, all of you, in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.